So hello viewers, welcome back to the channel. And now as I have promised, so we are now starting with the layer 3 of networking, which is routing. Or it's not a routing layer but it's called networking layer, and the responsibility of the networking layer is routing. So let's start the concept of routing. So this is the content. We'll introduce the topic. We'll see the switching analogy, we'll map it with the routing analogy, we'll see the protocols, we'll see the static routing, and then it will be followed by a practical demonstration on Packet Tracer and NS3. So let's start from the fundamentals. So obviously, you all know that OSI there is a reference model called OSI reference model, and from here, all of the networking layers are responsibility of all of the networking layers are defined. So as we start from the physical layer, there are bits, lights and waves. So basically electrical signals, optical signals, and there is something called electromagnetic waves. So this is a way of transforming or transformation for the signals, or you can say the transfer of bits, lights and waves using which they can communicate. Then there is a data link layer, which is layer 2, and at layer 2 we have seen lot of protocols already, like STP, MLAG, port channel, warp and VRRP. These are all the protocols that we have seen, and now we'll see the layer 3 of networking, which is a network layer in the OSI model. And there are lots of routing protocols like RIP, OSPF, ISIS, BGP, and there are some concept, not a routing protocol but VXLAN and EVPN. And the main responsibility of networking layer is nothing but routing. So we'll see the concept of routing, and if we can map it with the TCP/IP routing model, not routing model, TCP/IP networking model. So this is the OSI model. There are 7 layers, and this is the TCP/IP model, and there are just 4 layers. And layer 3 of networking is mapped with the layer 2 of TCP/IP model as internet. And these are some of the things that you must remember. And now routing. So routing is nothing but a process of selecting the efficient path for the packet that is being taken from the source to destination. And analogy is like you use the Google map, right, to reach at some specific destination. So that is nothing but the concept of routing being applied. And to start with the routing, we'll see first of all switching analogy, and then we'll map the switching analogy followed by the routing example. So imagine there is one society, and each there are some houses, and each houses is being mapped to some identification number. Let's say this house is identified as a house A, house B, and so on. Now let's say when there is someone in the house A, and he or she wants to talk to someone in house E. So as they are living in the same society, they'll know the address of each other, and they can just pass using the destination entity as the destination house. So let's say if someone in the house A wants to talk to someone in the house E, they'll just write source and destination as A and E, and that's how they are able to talk. And this is nothing but the switching analogy. And for that, what they'll do is each house will prepare one table, and inside that table what there will be fields. Let's say destination would be where you want to reach, so there will be house identification number, let's say ABC, and the address will be, let's say there will be some home number. Let's say house A is assigned 101, 102, 103, and such a way, so on, right? So each house will keep one table where they have the destination and particular room number. So by room number, not room number, by home number, they'll decide that if I want to go to this house, the person E, so this is the home number for that house. So This is nothing but a MAC table, and the destination, which is a MAC address, which is 48 bits, and there will be an interface. Let's say interface home number will be some interface, let's say Ethernet 1, Ethernet 2. So that's how there will be a table, and that is nothing but switching analogy. And there are some extra fields also in the MAC table, such as age and etc., which will keep track of the age of the MAC entry. So per, like, let's say fixed interval, the MAC entries will be removed, and when there will be a communication again from that house, there will be an entry in the MAC table. So that is nothing but the switching analogy. And now let's take an example of that same analogy, and we'll see that how routing can be mapped. Now let's say there are two societies, right? There can be a multiple societies, but let's just start from the simplest example. There are two societies, and let's say from this society there is a house E, and he or she wants to talk someone in the house J. So how they'll talk? So keeping table for all of the societies in all of the houses, that is not that is not some a solution that you can go with, because there may be a lots of other societies, and keeping track of each and every one in the single table might not be a great option. So what it will do is, so there is one solution. Let's say we put someone in the, what you can say, at the entry gate of the society, and each society will have that same person called postman. And if let's say these two postman knows that if someone from this society wants to talk to someone in someone wants to talk to someone in J, then J is living inside this society, and this postman knows that J is being here. So this postman, what it will do is, it will carry the message from, that is anyone, if let's say from this society wants to talk to anyone in this house, this postman and this postman will communicate, and they'll share the, what you can say, letter message. So let's say from E there is a message to J, and E knows that J is in some another society. So obviously what it will do is, it will pass message from E to destination X, and X is nothing but the what you can say, address of this postman. After that, this postman knows that if there is a destination J, so the postman of J, so basically this postman can connect to me with this particular destination. So basically it will pass the message to this postman. And then why basically the postman of this society knows that the J is being here, J is living here, so basically this will pass the message. So you see the source and destination being changed. And now let's say J wants to pass the message to E, so there will be a from J communication to E, and since E is living in another society and J doesn't know how to pass the message, so it will target, or it will tell the postman of this society, which is nothing but Y, to pass the message. And Y being received the message, it knows that if someone wants to communicate to E, X, postman X can help me. So basically from J the communication is to E. Obviously it will pass the destination to post office J, X. And now X postman will know that E is living here, so basically it will pass the message from J to E, and source is X and destination is E. So that's how routing is being done. But the question remains same, that how these two postmen will know that these are the things. If someone wants to go to J, this is the postman, because there might be a multiple society and each society have this postman. So how will they communicate and how will they know? So for them also there will be a table that these two postmen will maintain. And what it will does is, let's say this is society and there are houses from labeled A to F, and this postman will have entry of the destination. This postman will have the entry of destination A to F, if you want to reach to A to F, the next hop, which means you can connect with me. And if let's say someone wants to go to G to L, so what it will do, Postman X will do is it will go to each and every postman, and it will tell that if you want to reach to A to F, connect with me. And as this X postman will pass the message to Y, what Y will do is the postman will make an entry that A to F, if you want to connect to A to F, you can go to X postman. And similarly, this have the home houses labeled G to L. So this will have the entry in his table that if someone wants to reach to G to L, connect with me, and it will pass the message to postman X that if he wants to reach to G to L, connect with me. And that's how it will, this postman X will have entry if you want to connect to G to L, connect with Y. So this is the way the routing is being achieved. They will maintain this kind of table. And now if we can expand the scenario, so it leads us to protocol, which is nothing but a routing protocol. So let's say there are these are the roads and these are the three postmen. Each carries society, responsibility of one society. So basically A to F is here, G to L is here, and M to R is here. So this postman Y will tell X that if you want to reach to G to L, connect with Y, and that's how there will be an entry G to L, connect with next hop Y. And as being received this message, now Z will tell to X that if you want to reach to G to L, connect with me, not Y, because he has entry in his table with G to L. And now it will tell that if you want to reach to M2R, also you can connect with me. And as being received that message from the Z, what X will do is it will update the table and it will make an entry that if someone from this society wants to reach to M2R or G2L, you can connect with Z, and that Z has the entry. So this is how the communication will happen, and these are the respective tables of X and Z. And to achieve this kind of behavior, what you need is you need certain rules, and which are nothing but protocols. So let's see about protocols, routing protocols. So routing protocols are nothing but the way of communication for the devices on the internet to exchange the information of the networks that are reachable via them. So it is nothing but a communication of certain routers, certain devices. And if I can talk about the types, so there are two types: static routing and dynamic routing. As their name suggests, static is like a hardwired configuration, and dynamic is like the router will not the router, the devices will talk and they will exchange their routing table. So it will happen dynamically, and this is the hard coded by administrator. So let's see the basic example of static routing. And what I mean by static routing, so it is simplest way of achieving the routing. It's only useful for the smaller networks, obviously, because it's not reactive to failure on the path. So basically, let's say there are some intermediate links that is being broken, and you might not have connectivity to the next device. So static routing, it will not know that there are failure on the path, and it will not update the path because all the connection is hard coded. That's why it is static routing, and that's why there are no packet exchange involved, and all the things are nothing but hard coded configuration. And this is the basic example. So let's say this is the router, and these are the switches, and this switch carries LAN of 192.168.1.0/24, and there are lots of devices. And this switch carries the network 192.168.2.0/24. So this is a routing table of this device, and obviously this will have entry of 192.168.1.0/24. That is reachable via Ethernet 2 because this switch is connected on Ethernet 2. And similarly, this switch is connected on Ethernet 2, so that this network will be on Ethernet 2. And let's say for this link, we have another network being utilized, which is 10.10.10.0/30. So this will have entry in this routing table on Ethernet 1, and similarly over here. And now we'll configure static route. So we'll tell basically this router that if you want to reach this network, so basically this 192.168.2.0, then you can go via Ethernet 1. Basically this is the path, and this path is nothing but via Ethernet 1. And similarly to this router, if you want to reach to 192.168.1.0, so basically this is over here. So you can go via Ethernet 1 because it will, if it will go via Ethernet 1, it will land on this router, and this router knows that if you want to go to 192.168.1.0, you can go via Ethernet 2. And this makes the entry in each of these routing routers as this. So 192.168.2.0 is reachable via Ethernet 1. Also 1.0 is reachable via Ethernet 1. And these are the equivalent commands that you can use. So basically IP root, this is the classic command. These two commands are supported on Arista devices, and this is supported on Cisco devices. So now let's see the practical stuff. So this is the packet tracer example that I have created. So this is the same topology that we have just seen in the theory portion. So this is the network. Let me just label this network as 192.168.1.0/24, right? And this network is nothing but 192.168.2.0/24, and between these two routers we are utilizing 10.10.10.0/30, right? And now if we will observe route, and you see it will show that 10.10.10.0 is directly connected on this fast Ethernet 0/0, and this 192.168.1.0 is connected on 0/1, and 0/1 is nothing but this port. And if you just hover on this triangle, you will see FA0/1 is being shown. And if that is not possible to see, you can just go on global configuration mode, and you can just go under global configuration, show interfaces status, show IP interfaces. Show IP interface brief, and it will just show you this thing that fast Ethernet 0/1, it has been assigned this IP, and 0/0 it has been assigned this IP. And similarly you can observe for this router 1. And now on this PCs, what we have did is we have configured this IPv4 address, which is 192.168.1.1, and over here on the PC2 192.168.1.2 is being configured. Okay, you can see. And remember to just give this default gateway IP address, because whenever we want to communicate with someone on the different network, we need this default gateway to be configured. So this is nothing but the address of the postman. So we are mapping the things with the analogy that we have seen earlier. So this is the IP of postman. So whenever we want to connect to someone on the other different network will pass the message to this default gateway. So basically this is nothing but the postman. And now if we want to communicate to someone on the same network, let's say this PC2 wants to connect to PC0. So what we can do is we can just go here and we can type, so we can go on PC0 also, and over here if let's say PC0 wants to connect to PC2, so 192.168.1.2, and you can see we are getting the replies. There are no lost. Okay, so we are able to communicate with the PC2. But now let's say if we want to communicate with this PC1, which is on the different network with the IP 192.168.2.0. So let's see what happens in that scenario. 168.2.1. 192.168.2.1. So you can see these are the messages that is being thrown from 192.168.1.100, and this is nothing but the IP address of our postman, or you can also call it as a default gateway, right? So our postman is saying that sorry, I am not aware of this 192.168.2.1. I don't know where this person is. So to enable the communication between these two networks, what we need to do is we need to apply some kind of routing. So let's apply static routing. So we have seen the commands, right? So what we can do is we can just go in the global configuration mode and we can just type IP root, and let's say this is router 0. Okay, and let's say someone wants to go to 2.0 and subnet mask is /24. So you can go via 10.10.10.2, which is nothing but the IP of this router 1 on this link. Okay, and now if we just show IP root, so there will be this static route via this 10.10.10.2, and similarly on the router 1 we need someone over here, and we can also type over here that IP root 192.168.1.0 and subnet mask is 24. So you can go via 10.10.10.1, and 10.10.10.1 is router 0 IP address, right? And now we can also observe here the routing table using this show IP root, and you will see static entry for this network. You can go via this. And now from the PC0, from the command prompt, if I write 2.1, it will take first packet to build the entries in the routing table and MAC table, and then see later on these are the replies that you can see that is being received via 192.168.2.1. So that's the basic example of routing. And now you can just explore that what if we don't have the static route over here from this one of this router. Let's say on the router 0 we remove this static entry using this command no IP route 192.168.2.0 255.0 and 10.10.10.2. IP root. Okay, we need to go to global configuration mode, and if we see show IP root, where this should not be here, let's type conf t IP root 192.168.2.0. Okay, show IP root. So you see there is no static routing entry over here. So now let's try to simulate what will happen if we try to ping from PC0 to PC1. So see, switch received the message. It is being sent to router 0, but what router 0 will throw is, see, the device looks up the destination IP in the CEF table, but CEF table doesn't have the destination IP address, and so it will drop the packet, and it will basically send back an ICMP host unreachable message. So this will send the packet back to PC0 with the destination host unreachable message. So that's how the message will be formed. But let's see what happens if we send the packet from PC1 to PC0. So PC1 will send the packet to switch 1, switch 1 will send the packet to router 1. Now router 1 have entry. So let's say to reach 192.168.1.0, router 1 has entry that you can go via this path. So it will send the packet to router 0, and router 0 also knows that 192.168.1.0 is connected on this port, so it will send back the packet to this switch, and using this switch the message will pass to this PC0. Now PC0 will make a reply, and it will reply back to this PC1. This PC0 knows that PC1 is on the different network, so it will pass the message to the default gateway, which is nothing but the router 0. But now router 0 doesn't know that if you want to go to 192.168.2.0, you can go via this. So it will send again the ICMP host unreachable message, you see, to the destination. And PC1 will not receive the reply because router 0 doesn't know how to reach 192.168.2.0. This is the simulation stuff on the Cisco Packet Tracer. And that's it for this video. We'll see the NS3 stuff, that how you can simulate this same scenario on the NS3 and how you can observe the animation using NetAnim. So, but for now in this video, that's it. We'll see in the next video. Till then, keep learning and keep exploring.